This presentation is part of the TI in Focus AP Calculus video series. In this video, we'll discuss the scoring guidelines for the 2017 AP Calculus exam, free response question AB1 BC1. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I am a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors, and where appropriate, I'll present some very specific scoring examples. In this problem, a tank has a height of 10 feet, and the area of the horizontal cross-section of the tank at height h feet is given by the function a, and the function a is continuous and decreases as h increases, and selected values for a of h are given in the table. In part A, we need to use a left Riemann sum to approximate the volume of the tank, and we need to indicate the units of measure. In part B, we need to determine whether that approximation in part A was an overestimate or an underestimate for the volume of the tank. In part C, it's assumed that the area of the cross-section can be modeled by this function f, and based on this model, we need to find the volume of the tank. In part D, water is being pumped into the tank, and we know that when the height of the water is 5 feet, the height is increasing at a rate of 0.26 feet per minute. Using the model from part C, we need to find the rate at which the volume of the water is changing with respect to time when the height of the water is exactly 5 feet. Here are the scoring guidelines for this question. In this question, there was one global point for units. The units were asked for in parts A, C, and D, and the student received 1 point for presenting the correct units in all 3 parts. Part A was worth 2 points. The first point was a conceptual point for presenting the correct form of a left Riemann sum, and the second point was for the numerical approximation. Part B was worth 1 point for stating that the approximation in Part A is an overestimate with an appropriate reason. Part C was worth 2 points, 1 point for the correct integral and 1 point for presenting the correct numerical answer. Part D was worth 3 points, 2 points for presenting a correct expression for dv dt, and 1 point for the final correct numerical answer. Here are a few general comments about student performance on this question. This first question was contextual and calculator active, and these are usually pretty challenging for students. However, the students did reasonably well with the units, well, except in Part D. In Part A, most students were able to construct a left Riemann sum, and most students were able to recognize volume as the integral of a cross-sectional area. However, in Part D, many students found this problem difficult to start. They just couldn't come up with a correct expression for v of h. Although it's a little unusual, there was a global units point in this question. The student received 1 point for presenting the correct units in parts A, C, and D. The units had to be correct in all 3 parts in order to earn this point, and the units had to be connected to a number in at least 1 part. That means that bald, correct units in all 3 parts did not earn this point. The student had to present some appropriate work resulting in a numerical answer in at least 1 part, along with the correct units. In Part A, the first point was for presenting a correct left Riemann sum, and it must be a convincing left Riemann sum. The general philosophy used is that the readers are looking for a sum of products. And in this problem, we employ the 5 out of 6 rule. And that means that 5 out of the 6 terms in the sum of products must be correct to earn this point. And here are 2 examples that would earn this first point. The second point in Part A was for the correct numerical approximation. This expression would earn both points. It conveys the left Riemann sum, and remember that numerical answers do not need to be simplified. The correct numerical answer with some supporting work would earn this point, and in this example, the student would earn the approximation point, but not the left Riemann sum point. They have simply not communicated enough. There is no convincing left Riemann sum. And a bald 176.3 without any supporting work would not earn any credit in Part A. Here are some specific examples of possible student responses and how each would be scored. In the first example, the student has conveyed a left Riemann sum and presented the correct numerical answer. They would earn both points. In the second example, the student has presented 5 out of the 6 terms correctly. They would earn the first point, the left Riemann sum point, but they are not eligible to earn the approximation point. In the third example, the student has conveyed the correct left Riemann sum and presented the numerical approximation. They would earn both points. In the next example, the student has conveyed the correct left Riemann sum and earns the first point. However, the numerical approximation is not presented with the required degree of accuracy. They would not earn the second point, but they would not be penalized again in this problem for a similar decimal presentation error. In example 5, the student has presented the correct left Riemann sum and nothing else. They would earn 1 point. And in the last example, the student earns the approximation point only. There is insufficient evidence of the left Riemann sum. Part B was worth 1 point for correctly stating that the approximation in Part A is an overestimate with an appropriate reason. And the reason presented must involve the behavior of the function A. Here are some acceptable reasons. The approximation is an overestimate because A is decreasing. Or the approximation is an overestimate because the function is decreasing. Up till this point in the problem, we really only have one function, A, so we'll assume that that phrase, the function, refers to A. The approximation is an overestimate because the graph is decreasing. And we also accepted the approximation is an overestimate because the area is decreasing. We assume that means the cross-sectional area is decreasing. Here are some possible student responses in Part B that did not earn the point. The approximation is an overestimate because A prime is negative. Or the approximation is an overestimate because the slope of A is negative. The approximation is an overestimate because the rectangles are above the graph. The approximation is an overestimate because the function is decreasing and concave up. And in fact, any statements involving concavity did not earn this point. And finally, the approximation is an overestimate because the left endpoints are higher than the function. Please note that in each of these examples, we can almost understand what the student is trying to convey, but they simply have not used good communication to present a reason involving the function A. Part C was worth 2 points, 1 point for the correct integral and 1 point for the answer. And integral here on the scoring guidelines means definite integral, and of course the correct definite integral. Here are some specific examples. If the student presented the correct definite integral with a constant in front that's not 0 or not 1, they would earn the first point, but they're not eligible for the second point. They could also add a non-zero constant to the definite integral. They would also earn the first point, but not the second. And if there's a phantom pi in front of the definite integral, because some students believe that all volume calculations involve a pi, even with the correct numerical answer, this still only earns the first point. A bald correct answer without any supporting work does not earn any points. And an indefinite integral with the correct numerical answer earns only the second point. This is interpreted as poor communication of the definite integral. Part D was perhaps the most difficult part in this question. The first 2 points were for a correct expression for dv dt. And here's the general philosophy in scoring these 2 points. Finding the expression for dv dt involves both the chain rule and the fundamental theorem of calculus, and each of these concepts is worth 1 point. In scoring only the first 2 points, we will allow the student to use A instead of F, and here are some examples. In the first example, the student used A of H instead of F of H, and conceptually they have used the chain rule and the FTC, and so this earns 2 points. In the second example, the student presented a correct numerical answer using F of H, and would earn all 3 points. In the last example, there just isn't enough evidence that the student used F of H, and therefore they would earn only the first 2 points. Here are some examples of the chain rule without the fundamental theorem of calculus, and each of these would earn 1 point. In the first example, the student hasn't used the FTC to present an expression for dv/dh. In the next example, the student has not applied the FTC correctly, but there is evidence of the chain rule. And in example 3, w represents some other function the student has presented. There is just enough evidence of the chain rule, but not the fundamental theorem of calculus. Here are some examples of the fundamental theorem of calculus without the chain rule, and each of these is also worth 1 point. In the first 2 examples, there is sufficient evidence of the fundamental theorem of calculus. In example 3, with just dv/dh equal to f of 5 without any other work, we'll award 1 point for the fundamental theorem of calculus. And in the last example, I think we can see the FTC, but the chain rule is not properly applied. The last point in Part D was for the correct numerical answer. And here are some specific examples involving the answer point. The first 3 examples are pretty minimal, but each earns all 3 points. 2 points for the correct expression for dv/dt, and 1 point for the answer. In example 4, the student has minimally conveyed the correct expression for dv/dt. Without any other work, this earns 2 points. Note that this is not a numerical answer. The student did not evaluate f of 5, and therefore does not earn the answer point. And in example 5, the student earns one of the first 2 points, and the answer point. They have conveyed the FTC point, but not communicated the chain rule. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.